so we're going to start out with these five. Whoops, not these five. These five. Okay. So I want you to identify the reaction type, write it out in words, and balance it. See how much we remember from yesterday. Okay, what kind of reaction type are we looking at for number one? Simple decomposition, yeah. Okay, we got a compound breaking down into its two elements. All right, we need to balance this. What should I balance first? Nitrogen. Go with the biggest number first. There's 3 nitrogen on the reactant side. There's only 2 on the product side. How do I make 3 and 2 balance?
Find common denominator.
Right, find a common multiple, okay, or common denominator, okay, and that common multiple will be 6, okay. 3 times 2 is 6, 2 times 3 is 6. All right, my nitrogens work. Putting this 2 here, though, also affects my oxygen. How many oxygen do I have? 4. Now I have 4 over there. Okay. Questions on that? All right, written out in words. Trinitrogen dioxide. Okay, put an arrow. Nitrogen plus oxygen. I had a good question in my period 4 class about how we write these. Okay, I think maybe it was this class. Do I need to write like a full sentence like dinitrogen trioxide decomposes into blah, blah, blah? No. Just write it like that. Okay? Just the names with the arrows and the plus signs. That's all you have to write. Okay? I'm not looking for an interesting story about the tragedy of the decomposition of trinitrogen dioxide. Okay? All right, how many people have done number 2?
I have a question.
Okay, my question.
Just number 3, we haven't quite got there yet.
Yep.
But with the 14, if you're writing that out, like we don't have the.
Yeah. I won't give you one like for assessment that has a prefix that's bigger than 10.
Okay.
Yeah. If I do, it would be, I would give you the name and the formula.
Okay.
Yeah. All right. So for number 2, what kind of reaction are we looking at with an element reacting with an ionic compound?
Single replacement.
Single replacement. Okay. In this single replacement reaction, we've got chlorines that are out of balance. Okay, it's the only thing right now that's out of balance, but once I balance it, I'll have to fix a couple of other things. We have that 3 and 2 again, lowest common multiple being 6. So a 3 here gets me my 6 chlorines on that side. A 2 here gets me 6 chlorines on the reactant side. This 2 also affects the iron, so a 2 needs to go here. This 3 also affects the calcium, so I need to go back over here and make sure that I have 3 on the calcium. Okay, and then written out in words, calcium plus iron, Roman numeral 3, chloride. You'd be surprised how often people forget that when they're writing out reactions. They forget all about Roman numerals, which unfortunately makes it wrong. So don't forget about Roman numerals. Okay, gives iron. Do I need to put a Roman numeral beside iron when it's an element? No, because elements don't have charges. Okay, they have charges when they're an ion in an ionic compound, but not here. Okay, that's also a very common mistake. And then we have calcium chloride. Okay, keep going. I'll give you a few more minutes and then we'll go through 3, 4, and 5. Okay, so for number 3, we've got what kind of reaction?
Combustion.
It's a combustion reaction. We have a hydrocarbon reacting with oxygen. Our products are carbon dioxide and water. Okay, so combust would be our reaction type. And now we need to balance it. 2 rules for balancing combustion reactions. Balance alphabetically and the rule of 2. Do I need both?
Yes.
Yes, there's an even number of carbons, so I need to start with a 2. So now I've applied the rule of 2. Okay, and now I need to balance alphabetically. 2 times 6 carbons is 12, so I need a 12 here. Okay, 2 times 14 is 28. 14 times 2 is 28. Now I need to balance my oxygens. So I've got 24 oxygens in the carbon dioxide, plus another 14 is 38. 19 times 2 is 38. Okay. when we're balancing this stuff is hexane. That's all I'm gonna write because I don't remember what the prefix for 14 is either. Okay, hexane plus oxygen, and on a test, like I said, I wouldn't give you one where the prefixes are bigger than 10. Okay, that's gonna give us carbon dioxide and water. Okay, questions on 3? Okay, let's have a look at 4. So on number 4, I've got chlorine reacting with lithium. So we'll just write it out in words while we do this. Chlorine plus lithium gives me an ionic compound, lithium chloride. Okay, what kind of reaction is that? Synthesis reaction. Okay, now I need to balance it. What should I balance first? Chlorine. Okay, there's 2 on the reactant side. Now there are 2 on the product side. Am I done? Right, I need to make sure the lithium are balanced as well. Okay. And for number 5, I've got magnesium fluoride, which is an ionic compound, reacting with cobalt 3 nitrate, also an ionic compound. That's going to produce magnesium nitrate. And cobalt 3 chloride. Alright, so that's what that should look like in words. What kind of reaction is it? Double replacement. Everything is ionic. Alright, what should I balance first? Nitrate, yeah, okay, I can balance fluorine. It's a 3 on the product side too. It doesn't really matter. Right, so how many nitrates do I have? 3. Okay, how many over here? 2. Lowest common multiple? Okay, so a 3 in front of this will give me 6. A 2 in front of this will give me 6. That 3 applies to the magnesium, so I've got to go back over here and apply it to the magnesium. When I do that, it gives me 6 fluorines. So, I need to go over to the product side and make sure I have 6 fluorines. That gives me 2 cobalts, which just happens to work out with the 2 I wrote over here. Always a good sign when the last one works out because of everything else done. Okay? If it doesn't, then you get to start over with something else. That happens once in a while. Don't get too discouraged. It happens to the best of us. All right. Questions on any of those? Okay. Is it making sense? Are we getting at least the idea of the pattern of the reaction types? Okay, because that's actually really important when we get moving forward and we're actually predicting the products of a reaction. You have to be able to identify the reaction from just the reactants. Okay, you won't have the whole reaction there. You'll just get the reactants, and then you'll have to go, okay, because that's 2 elements, that's a synthesis reaction. What happens in a synthesis reaction is the 2 elements join together to make a compound, and you make the compound. You're just predicting the product. But you can recognize all of the reaction types from just the reactants. They all have a different setup. Okay? Does that make sense? Right. So, in your worksheet booklet is a sheet that looks like similar to this. We'll just call it up so you see exactly what it looks like. Okay, and what I'm going to do is I'm going to have you work on that, and I'm going to post the keys in the stream here in Google Classroom, so you can kind of check as you go. All right, so in that class work tab, you got your worksheet packages, and it's the first one. So you got all these naming worksheets too, guys, if we were talking about those the other day. Lots of them. All right, so this is the one I'm talking about here. It's on page 8 of that digital workbook. Right? And so what I want you to do for these ones, balance the equation, write the word equation, so just like what we were doing, and write the type of reaction, synthesis, decomp, single replacement, double replacement, or combustion. right? There's 13 that are giving you the formulas and asking you to go to the names, and then there are 9 that are the other way, where I give you the word equation, and you need to write the formula equation and go from there. All right, so we just need to practice this. The only way to get good at it is to repeat it. Okay, if you're needing help, something you're not understanding, today's the day to ask. Okay, we can do them on the board together, or I can come around and help you individually. That's entirely up to you. Okay,
So we do all the 13 and then all the 9?
or you can go 1, 1, 1, 2, 2, 3, 3 if you want. Doesn't matter.
But
to
you
me.
have to finish them all or no?
Well, yes.
Okay.
I go.
Yeah. You can go after. I'm the one who's supposed to get permission for that, but you know, it's all right.
That was